Which rhyme scheme would you expect the first 8 lines of a Petrarchan sonnet to have? Question 11. Listen again to part of the talk. What does the professor imply when he says this? The final characteristics of sonnets is that they are written in iambic pentameter. We defined this 1 week ago, but review never hurts, right? Listen to part of a lecture in a general science class. Good afternoon, everyone. Our topic today is electrical conductivity. As you'll recall from previous classes, electricity flows through materials in the form of an electric charge or current. The direction of flow depends on whether the particles are positively or negatively charged, and on the material through which the charge is flowing. For charge to flow through a material, that material must possess a property called electrical conductivity. Basically, conductivity can be understood as the ability of a material to allow electrical charge to flow through it. Some materials allow electric charge to flow through them relatively easy in one or more directions. We call these materials conductors. Other materials either do not conduct electricity, that is, they do not allow electric charge to flow through them, or conduct it very poorly. We call these materials insulators. To make these important concepts clear, let's think of a common scenario. Let's say you're using your laptop and you notice that the battery level is getting low. So you take the power cable, plug one end into the wall socket, and the other end into your laptop. Right away, the battery starts recharging. We've all done this hundreds of times, right? But how does it work? Well, inside the power cable is a metal wire. Most metals are very good conductors. They allow electric charge to flow freely. And when you plug the cable into the wall, electricity flows through the wire and into your laptop. But metal is such a good conductor that if you were to touch the wire, the electricity would pass from the wire into your body and give you a shock. So the wire inside the power cable is covered with some kind of plastic or rubber insulator that does not allow electricity to flow. Make sense? Most materials are either conductors or insulators, but there are 2 special classes of materials that I want to touch on, beginning with superconductors. Most conductors have a certain amount of resistance, that is, they resist the flow of electricity to some extent. This is undesirable because it results in a loss of energy. I'm sure you're familiar with the idea that wires become hot when electricity flows through them. The heat is caused by electrical resistance. Superconductors are materials with zero resistance, so electricity can flow through them without ever losing energy. Superconducting materials have an enormous range of uses and are incredibly efficient. Well, that's in theory. In practice, such materials are not especially useful because most of them only work at very, very cold temperatures. There's one more class of material I'd like to discuss, semiconductors, which are more resistant to the flow of electricity than conductors, but much less resistant than insulators. In other words, electricity can flow through them, but not easily. This may not sound like a useful property, but as you know, semiconductors have had a massive impact on society because they are a key element in every electronic device we own. Why? Well, semiconductors can be manufactured with specific, useful properties. For example, they can allow current to flow more easily in one direction than another, or to flow more easily at certain temperatures, or to flow when there is light or heat, or you get the idea. Again, why are such properties valuable? Well, they mean that semiconductors have valuable uses. These include being used to increase or amplify an electrical signal, or being used to switch a signal in some way, or to convert a signal from one form to another. And these properties of amplification, conversion, and switching are all key processes in modern electronic computing. So, in essence, semiconductors are at the heart of computers. Question 12. How does the professor organize her lecture? Question 13. How does the professor define insulators? Question 14. Why does the professor mention laptop computers? Question 15. The professor discusses several classes of materials. Indicate which information matches each class of material. Question 16. According to the professor, what valuable properties do semiconductors have? Question 17. Listen again to part of the talk. Why does the professor say this? Well, semiconductors can be manufactured with specific, useful properties. For example, they can allow current to flow more easily in one direction than another, or to flow more easily at certain temperatures, or to flow when there is light or heat, or you get the idea. Again, why are such properties valuable? Well, they mean that semiconductors have valuable uses.